I'm Davide. I will cover this last session for today, which is about service function chaining. So first of all, what is service function chaining? Well, I don't know if this is something that you already know or not, but basically is this. So you have a concatenation or a chaining of basic services, which can be virtualized or not. And in this way, we are chaining these basic services in order to compose a more complex one, so that may need from the two end user. So we pretty much know how to do network services like this, so in which you have two endpoints, for example, and a couple of VFs, but what about the forwarding? If you start traffic from endpoint 1 to endpoint 2, these are connected to the same network, so the traffic will go directly from one endpoint to the other one and will not cross the VF that you created. So how can we enforce this traffic to go through that virtual function in that specific order? Well, the classical way of doing so is using an SDN controller, which is controlling different OpenFlow capable switches, in which is inserting OpenFlow rules that will steer the traffic according to our needs. And this is exactly what happens inside OpenStack. I don't know if you know that, but in each OpenStack node, you have several OpenView switches, which can be controlled by the Neutron, which is the internal SDN controller of OpenStack. And this controller is able to inject OpenFlow rules inside these switches. And this is how they are connected. So you have the integration bridges, for example, which is the one that connects all the virtual machine running inside that node. You have the tunneling bridges, which is the one that connect to other OpenStack nodes, and then at the external bridges, which is the one that connect to external networks. And as I said, Neutron is able to, thanks to OpenFlow rules, to steer traffic and create service function chaining inside OpenStack. And this is exactly what OSM leverages to do it. This is a bit of history, we can say, about the SFC status in OSM. It's available since OSM release 3, and it works only with OpenStack Queens or higher. And unfortunately, it only supports asymmetrical chains, but we will see what I mean with that. And uses SFC encapsulation with MPLS, so not NSH anymore. They moved back to MPLS, probably due to some misconfiguration of NSH inside OpenStack. There are several bugs also related to OpenView switches, so that's probably why they moved back to MPLS. And it grants the possibility of specifying the traffic using these fields. So you see IP protocols, source IP address, destination IP address, source port or destination port of the traffic that I want to steer. And so this is again what is the status of SFC inside OSM. Now you can specify separate ingress and egress port for each VNF, which wasn't possible in the past. As I said, you can only do asymmetrical chain. It means chains that goes just one way, not on both ways, which is, on the contrary, it's possible to do it directly with OpenStack. So it's still in development, the possibility of doing that directly on OSM. Non-transparent service function, what I mean? In the standards, there are two types of VNF that can be used inside the service function chaining. There are the SFC aware and the SFC unaware. What's the difference? The SFC aware are virtual functions that can understand the encapsulation method that are used, for example, MPLS. So they can take the MPLS label, do whatever they need to do based on that, and take decision of the next Instead, the SFC unaware are service functions that don't know what to do, basically, with this encapsulation method. So they need the so-called SFC proxy, an object that stays before the virtual function, removes the encapsulation method, forward the packet to the service function, get the packet back, and reinsert the encapsulation method. And right now, it only works with the unaware service function. So when we will capture the traffic inside the VNF of the chain, we will not see any MPLS label. And the proxy is done directly on the OpenBOO switches by the SFC extension of OpenStack. Another thing that we are still managing to try to find a way to do it is the branching and joining. So if it's possible to split the path in two parts and then maybe join it in another part of the chain. The service function tab is not supported yet. What is a service function tab? Is basically a service function which is not part of the what we can call the active path of the packets, but just receive a replica of this. For example, an IDS that just needs to keep track of the packet going through, but doesn't need to take any action on that. As I said, the research is still ongoing. How can we do SFC in OSM? There's a new part that we will add to the network service descriptor, which is done in this way. So first of all, we need to define the rendered service path. What is the rendered service path? It's basically the path that we want the packet to go through. We need to specify the list of connection point of the VNF and the order that we want them to go through. So we see, as we usually do, the index of the VNFD that are the one that we put inside the constituent VNFD list at the beginning of the network descriptor. And then we have to specify the order in which the different VNF will be traversed inside our rendered service path, and the ingress and egress connection point of that specific VNF. Once we define the rendered service path, we have to define what are the characteristics of this traffic. So we need to define a classifier which has the list called match attributes, in which we specify, as I said, different parameters. So for example, the IP protocol with using the identifier. So for example, 1 will be ICMP, 6 will be TCP, 17 will be UDP. Then we have to specify the destination IP address, the source IP address, the destination port, and the source port, of course, only if we're using TCP or UDP. Then that's probably the trickiest part. So the last three lines, what are these? These represent the point from which the traffic will enter our service function chain. Why this is needed? To avoid loops inside the OpenFlow tables of OpenStack. If you don't specify from which point the traffic will come for the first time, there's a probability of creating loops inside the OpenFlow tables. That's why it's needed to add this particular parameter. And this is simply, we say this classifier is linked to the rendered service path specified by this ID. So we are practically linking the path and the classifier of the traffic. Okay, so I think we can move on with the hands-on session. This will be our scenario, very simple, just to show you how it works. First of all, we can download and onboard these descriptors inside our OSM. So we can onboard the packages inside our OSM the usual way. Now you can see that inside our packages there are the part related to the SFC that I have described before inside the theoretical part, and then we can also go and check the presence of already instantiated service function chain inside our OpenStack. We can see the project that is empty, and via command line, which is the only way you can use to check the presence of port chain or flow classifier inside your OpenStack, we see that the list is empty. And so we can go on with the onboarding and the instantiation the usual way. We set the name, we set a description, and we select our OpenStack. We also insert an additional parameter to use the already present network inside our OpenStack, and then we wait for the creation. Okay, we see the first machine coming up inside the OpenStack network topology, which, as you can see, have the same IP addresses that we specified inside the descriptors. And then we can, as soon as it finishes, we can go and check whether the port chain has been created. So you see here the port chain, and you see here the flow classifier. You see that the identifier of the flow classifier of our port chain is exactly the same as the one below, which has the parameter that we defined inside the descriptor. We can now go and access our VM, and we're going to see if the chain was correctly instantiated or not, and we're going to do so by generating the correct type of traffic that we selected. So in the video you see on the left the VM in the middle, and on the top right part the source of our traffic, and on the bottom right part the destination. So we will start by opening a connection on port 80 on our destination, and we will start by generating traffic directed to that port from the source. So as you can see here, we are opening a connection to our port 80, which will be the one that will go through the middle VM. So we see that the messages are going from source to destination correctly. And now we're going to check if the packages are going through the middle VM. We're going to do that with TCP dump to capture the packet that goes through our interface. Again, if we try to send a message, we type enter, we see two packets. One is the one that is entering the VM, and the other one is the one going out of our VM. You can see it from the MAC addresses. Now we're going to show that if we do the same things but on another port, for example 81, we will not see any packets on the middle VM. This is another proof proving that the classifier that we choose was correctly instantiated inside OpenStack. As you can see, the capture is empty. Now we can delete the service chain, the network service, sorry, and of course the VM will be deleted, the network too, and also all the component related to the service function chaining, as you can see from the command line of OpenStack. So we just saw the native solution of OpenStack for service chaining. Another way which has become more and more relevant nowadays is segment routing, is a source routing approach toward service function chaining, in which the whole list of service function of your chain is inserted directly from the ingress node of your segment routing domain. And this list is basically a list of segments. Each segment will represent a function inside your chain. And this segment identifier can be expressed in two ways: by means of MPLS label if you're using IPv4, or directly as a list of IPv6 addresses, which will be the case that we will going to address in this demo. So we try to connect these two words, so the word of segment routing and OSM, and with that, with the Juju action. So we can load the descriptor here, and we will go through them and demo it for you. So first of all, there's the action in charge of creating your segment routing chain. As you can see, you have the same parameter that we saw before for the creation of the classifier. So IP address for destination, source, protocol used, and the destination and source port. Then you have one of the most important parameter, which is the list, that will be, as I said, the list of segment that will be part of your chain. The use of Juju and action grants us the possibility also to dynamically interact with the chain. In the previous case, so the one directly leveraging OpenStack, you can only create chain during the instantiation phase and you cannot change it. Instead, with this approach, you can also delete or update your chain with these two actions, the del chain and the update chain, that take different parameters. And I'm going to show them to you in the next demo. So this will be our scenario for the demo. Again, similar to the one before, 2 endpoint and 2 VNF in the middle. Again, we are using IPv6 because we are using SRv6, so we need IPv6 addresses. So we will start with a chain like this, similar to the one before, so just a VNF in the middle, but we are going also to update it, as you can see here, so dynamically, without the needs of reinstantiate all the network service. We're going to change the path that the traffic will go through. So let's go on with the demo. So we can start with the onboarding of the packages for the demo, that are the ones that I showed you before in the presentation. You can do easily with a drag and drop. We can now move on with the deployment of our network service. We can do it the usual way, and then we wait for its creation. Okay, so the deployment is finished, and here you can see the machine and the network that you wanted. One with IPv4 that we will use for accessing the machine and to launch the Juju action, and the other one for the IPv6 data plane. Okay, now we can go on with the demo. So you see on the top left terminal the machine that we will use as a source of our traffic, on the bottom left one the destination, and on the right the two VM that we'll use to steer the traffic into. So in order to check if the traffic is going inside the machines, we are using TCP dump, and as before we are using netcat to generate traffic. Now you see that the traffic is going directly from source to destination because we haven't inserted a chain yet. So, and we call the action create, and we pass all the different parameters that we need. We will see that the traffic will go exactly towards the machine with the address that ends with an F. Okay, specify the list, the source IP, the destination IP, and so on. Okay, so now if we go back to our terminal and we start generating traffic the same way that we did before, we expect to see traffic on the top right terminal. And as you can see, here they are. We see two packets, the one that is the one that is incoming and the one exiting the machine. You can see the parameter segment left, which means how many segments we need to cross before reaching destination. So you see that we enter with 1 and we go out with 0, meaning that this was the last hop in our chain. So we can try to update the chain. So we want to change the path of the traffic. So we add also the other machine. So we trigger the execution, and we go back to the terminals part, and we expect to see packets in both of the right terminal. Okay, again, same stuff as before, but we see that we have 2 segments left in the incoming packet and 1 of the outgoing packets. Instead of the bottom right terminal, which is the last hop, so the one that we just added, we have the 1 and 0 segment left, 1 for the incoming and 0 for the outgoing. And if you want to go back to the original state, so the one without any chain, we simply call the action del chain. And again, if you go back to our terminal and we start generating traffic, we see that we don't have any packets inside the VM on the right part of the screen. And this is just a way to demonstrate the correctness of this solution.